Hope this whiteboard screen is visible to all of you. Now, before going to mathematical stuff, I'm trying to compare the natural intelligence or natural learning, what we are following, with the artificial intelligence, or we can call it as a machine learning, or we can call it as a deep learning. I'm trying to compare these two. For ease of understanding of the artificial intelligence or machine learning or deep learning, I'm trying to compare with the natural learning or natural intelligence. Okay. For example, let us assume generally how we will learn a particular concept or whatever it may be. Or we can start from our school days. Let's assume I have a child. So I have a child. Okay. So now what we will do? So my intention is I want to give a good education to my child. I'm expecting my child will learn some new things and she learn something new concepts. So that's why I joined my child into some school wherever. Okay. So here my child will learn something, right? Like what we did when we are joined in the school. We started with some Telugu letters, like if it is a Telugu people, it is like nowadays everyone will start from A, B, C, D. Whatever it may be, education is first step is started from there, right? So the child will learn here in a school. If you join our child into the school, the child will learn some new information, right? Maybe A, B, C, D, or maybe or something else, depending upon the schools, depending upon the region where we are from. Some data, some information that child will learn once he entered into the school. Is it right? So here, who will learn? So our child will learn. That's called natural intelligence. That's what we have. Right? So now, that means to learn something, the child is available. To learn something, the child will available in a school. Right? If only child is exist, he will learn everything. Suppose my child is there, I have a daughter. If I join my daughter into a school, she will learn everything? No. Right? So what the procedure? If I join my child in a particular school, the school will decide what they have to give to my child to learn. They may give some letters like A, B, C, D, or they may give some letters, Telugu letters, whatever it may be, or they give some like Hindi letters like this, some data they must study, right? Hope you understand. Suppose my intention is my child to learn some English alphabets, then they will come with this ABCD. My intention is my child will learn some like this, they will come with this type of Telugu alphabets, letters. And if it is Hindi, it is like this. So depending upon the what we are expecting to our child will learn, depending upon that one, so they will provide that information, right? They will come up with that information, right? So that means, so this is the things which are required to learn the child, right? Now another question. Fine, my daughter is there, my daughter is available, and of course I have the information of English alphabets and different small words, animal names. Every information is available to learn, to give my child to learn something. Then why we think of different schools? So I am in Warangal. So I want to join my child. I want to send my child to a school, a particular school. Why? Well, I have the multiple schools, right? I have multiple schools. But then why? You have a child, and in every school they will teach that ABCD only. I have a child, and every school same charts ABCD. Let us do. So those are available. Then why I'm searching for the multiple schools?
₹1 ఏమవుతాయమ్మా?
Because Because why we are searching for the different schools? Because different schools will follow different approach to make my child learn that ABCD information. Different schools follow different approaches, different methods to make my child learn that ABCD, whatever it may be. Different schools, different approaches. Maybe some schools, they will give ABCD and ask the children to write multiple times on the ABCD. Generally, when I am joined in the first class in my government schools, then I have a small slate. They write and I have a slate pencil and I am writing multiple times. That is one approach that was followed at that time. Nowadays, and many approaches are coming. Something that activity based. So nowadays my daughter is cutting the ABCD letters. So they learn some like that, some activity based learning, and different approaches are coming with different by the different schools. Different approaches, same ABCD, the child will learn, I also learn. My daughter is learn, I also learn. But the approach may be a different, right? At that time, I have a slate, I write multiple times on the slate. But now they give one book and a rule book and write and she wrote multiple times, one by one, multiple times, and she will learn like this. That are the different approaches. And nowadays also different schools follow the different approaches. So different schools and different approaches, right? So we have the approach. There is one approach will be, different approaches will be followed. So now see, so I have a child and I want to make my child learn English. Let's assume I want to make my child to learn some English. Then the information, what the first thing we have to feed it to my children, that is the ABCD. But ABCDs are available everywhere. In every chart, if I go to bookstore, they will give the ABCD textbook, different books, right? Then why I'm searching for the different schools to admit my child? Because maybe I feel that the school approach is different. It's very active, very good approach they are following, so that my child will learn very fastly. Different approach, following the different. So that the different approaches that is required. So if you want our child to learn something on a particular area, that may be English or Telugu, whatever it may be, so we have to feed that information with the right approach based on the school where we are joining. Simple way I'm trying to explain that generally what natural intelligence or natural learning is happening. Maybe slightly different, but almost like this only. Now coming to the artificial intelligence. So the name itself says that it's a artificial intelligence or machine learning or deep learning. So intelligence which was developed artificially in the form of some programming on a computing machines by mimicking the natural intelligence what available across the globe. That's it. So artificial intelligence, nothing but the intelligence which was developed in the form of a computer programming by taking the inspiration from the natural intelligence or the natural learning or whatever available across the globe naturally. Right? So many, like say, I think some people who are doing PhD and MTech in the power systems, they may they know about the bio-inspired learning algorithms. So like based on the swarming behavior of the ants, that ants how they search for the food, the ant colony optimization, based on the movement of the birds, particle swarm optimization, Firefly algorithm. So what's it? All these algorithms are mimicking the natural intelligence available across the globe. And we are converting in the form of the mathematical model. We are converting in the form of a computer programming, and we are using for our applications. That's part of natural artificial intelligence. And what available is from where we are taking the inspiration. From where we are taking the inspiration. So that is called as our natural intelligence. So coming to this, in this case, machine learning or artificial intelligence. So artificial intelligence is nothing but the intelligence which was developed in the form of the mathematical modeling, in the form of the computer programming, by mimicking or by taking the inspiration from the natural intelligence across available in the globe. Now trying to mimic both, right? Now, in case of the natural intelligence, my child wants to learn. I want to make my child to learn something. Now, what comes here in artificial intelligence, it's coming as model. That may be a machine learning model or deep learning model. It may be a machine learning model or deep learning model. The model we will develop a model. That model will learn. So that means my child in natural intelligence, we are mimicking the models. We are developing the models. Especially one model is called the artificial neural network model, which will mimic the human brain. Human brain is a natural intelligence, like a child has a human brain. And the same, we are converting into the functioning of the human brain and architecture of the human brain, we are converted into the mathematical modeling, and we are making it to the computer programming, and we are using the same neural network model for the predictions, right? So in the natural intelligence, my child, she has a human brain naturally available. That brain helps her to learn something. Similarly, we will develop a model by mimicking the human brain or some other parameter. Now, that model is a analogy of your child or human brain, whatever it may be, in the artificial intelligence. So here I want to make my child to learn something, whereas here I have a model to learn something. Good. Okay. So we have the different models actually in the machine learning. We have the different models like simple linear regression model, which is a very basic one actually. So I am trying to discuss with this one only because I am trying to focus on not multiple models. I'm trying to discuss on different gradient descent algorithm variants. And we have the multiple linear regression model. If possible, I'm trying to discuss about this one also. And we have the polynomial regression model, and we have the logistic regression model, and we have the different descent tree, and we have the random forest, and we have the support vector machines, and we have the neural networks, ANN, artificial neural networks, and we have the convolutional neural networks, and so on. So we have the multiple machine learning or deep learning models. We have the multiple machine learning and deep learning models. Those models will learn based on our application. See, my child, my daughter, I took admission for my child into the school, and she will learn based on the current circumstances. So I want to my child to learn English. Then the school will provide the information related to the English alphabet, some words like that. Here also, your model will learn based on which application you are working. So it is an analogy for the human child and with the machine learning or deep learning models. So we have the multiple models for the multiple purposes. Okay. Now what is the another part here? So once the human child is available, then we have to give the data, information, right? We have to give that information. Without data, without information, what she will learn, right? So in the school, they may provide the ABCD. That is the data that is given to my child to learn the English. Similarly, what is the analogy here? So it is the information, and analogy in the AI machine learning is a very, very important, that is called data. So data is analogy for this one, because if my child wants to learn English, I will give the ABCD. That is information or data. Similarly, in the model also, if you want to make my model learn something, I have to feed the data to my model. Which data we have to feed? That depending upon the application on which you want to work. For example, I want to build a machine learning model to forecast the electric power load, let's assume. Then I have to give the load data to my machine learning model to learn. Suppose if I want to estimate the market price, then I have to give the price data to my machine learning model to learn. Okay. Similarly, in which application you are working? Suppose if you are working on the disease, that means crop disease prediction based on the leaf image, then I have to feed the leaf image data for the disease prediction or disease estimation. So on which problem we are working, accordingly we have to feed the data, right? If my child want to learn English, I will give the ABCD. If my child want to learn Hindi, then I will give the information or data like this, like this. If my child wants to learn Telugu, then I will give this type of data. So what we want to make our child learn, accordingly we have to feed the data, right? Suppose if I join BTech EEE, so the college will provide the EEE data, maybe motors, generators, power systems, power electronics, like that. And student is joined in an engineering college in a CSE department, they will give the CSE data to learn, right? So like this, so if we have a model to make that model to learn something, then what to do? So you have to give that data. That respond data we have to provide. Hope you understand. So that's why I'm trying to compare analogy between. So I think you are clear with the model, you are clear with the data. It's very, very important. Data is very, very important. If you feed the wrong data, then your model also learn wrong way. Same. Suppose if let us assume, if I tell my child that so this is A. Suppose if I tell my child as this is A, then what she will do? She will write A like this. And when someone asks her write A, then she will write B. Why? Because I'm providing the wrong data. She is innocent. Our model also like innocent. We don't know anything. Your machine learning model don't know anything. What data you are feeding, that will learn accordingly. So that's why it's a very, very crucial at the time of the data preparation. At the time of the data preparation, it is very, very important. Then, so that's why we have to, when we are working on any AI related project, we have to spend much amount of time on the data preparation. Maybe that consists of data collection, data analysis, data pre-processing, everything will comes into the place. So that is very important. Otherwise, your model will learn in the wrong direction. It will not learn properly as per your requirement. Okay. Now I think you are clear with the data, how we are correlating with these things, and you are clear with the model, how we are correlating this one. Now coming to that part, approach. So what is the approach? So even though I have the ABCD alphabets, even though I have a child to learn, then what approach that school is following? What approach the school is following to make my child learn that ABCD alphabets, that's called approach. That means what the school will do? The school people, the school management will admit my child to learn ABCD data with their approach, what they defined approach they will apply to learn. Similarly, in the machine learning model also, we call it as a algorithms we are using. So we are using some algorithms. That algorithm will decide. That algorithm is nothing but an approach. The algorithm will decide the step-by-step approach, step-by-step procedure. That algorithm will tell the machine learning model to learn using this data. Here also same thing, right? Approach means what approach they are following to learn ABCD to my child, to make learn ABCD to my child. How my child will learn ABCD? They will follow some approach. Similarly, this algorithm will give some step-by-step approach so that your machine learning model will learn based on the available data, based on your problem statement. So these three are main things which I'm trying to correlate with our natural intelligence. Now, in this algorithm, we are using the optimization or optimizers. The different optimizers or the optimization techniques are involved in an algorithm. These optimization techniques involved in the algorithm. These optimization techniques will help the model. These optimization techniques will help the machine learning model to update its parameter in order to learn based on the given data. So we have an algorithms. So in that algorithm, nothing but we are using the different optimization techniques. We are using the different optimizers. This optimization technique will help the machine learning model. This algorithm or optimization technique will help the machine learning model to update its model parameters based on the given data. Hope it's clear for you. Okay. So that's why these optimizers are very, very crucial role. Okay. So actually, when we are using the libraries, we will call like SGD, stochastic gradient. We will call as ADA grad, and we will call it as a ADA delta. Different optimizers are there. But when we are using the library, we can simply pass the term SGD. It will take care of learning of machine learning model based on the data what you are feeding. But it's better to understand how these optimizers will help to update the machine learning models in order to learn properly based on the given data. You may ask the question, sir, without knowing the background of the mathematics, can't we build the machine learning model? Can't we make a machine learning model to learn? Yes, you can. Simply using the library and pass the optimizers what you want. But it's like a black box. You don't know what happened, how this optimizer will help the machine learning model to learn, how this optimizer will help the machine learning model to update the model parameters for the given data. You can implement, but you don't know what happened. So as we are a learners, it's better to understand initially what happening behind it, right? So hope you the complete scenario, hope you understand the complete scenario of analogy between the natural intelligence and the artificial intelligence. Now we will focus on this part. Now we are focusing on this part, optimization or optimization techniques. Okay. So the next 2 hours, I'm trying to give some basic idea about the optimization techniques, what are the different type of optimization techniques, and how we solve the optimization problem using MATLAB and Python. That is the flow for today's class. Now, I will move to the new screen. Fine. Hope you okay. Okay. First, we will discuss about the optimization. So what mean by the optimization? First, we will try to discuss about the what mean by the optimization. So optimization is nothing but process of either maximizing or minimizing a particular objective. We're trying to maximize. We are trying to maximize or trying to minimize, trying to maximize or trying to minimize a particular objective or objective function. So that is called as the optimization, either maximization or minimization. So in general terms, let us assume, suppose if we go to a supermarket like a D-Mart or Reliance supermarket, whatever it may be, or let's assume I developed, I started a business like a supermarket business, let us assume. So what is my objective generally? So my objective is generally, so suppose if I'm going for any business, I'm trying to maximize my profit. I'm trying to maximize my profit, right? I'm trying to maximize. I want to go for the good business, and final motto is I want to get good profit, maximize my profit. So maybe for that one, I will give different schemes. I am coming with different schemes and different ideas to attract the customers like that. Whatever it may be, what I am doing really. So my ultimate goal is to maximize the profit. So that is the one of the optimization problem. Suppose as a customer, someone entering into my supermarket, as a someone entering into my supermarket, then what is his objective actually? So generally, what is the objective? If I am thinking as a customer, if I'm entering into any supermarket, my intention is for this month I am trying to purchase what is the basic requirement, but I am trying to minimize my cost of expenses. So I want trying to minimize the cost of expenses. Based on maybe change some constraints, all the things will come into picture. And finally, I'm trying to minimize my cost of expenses as much as possible. So cost of minimizing the cost of expenses means if I don't purchase anything, no cost. That's fine. That's not condition. I have a constraint. I have some needs for a month. I have to purchase. But at the same time, I'm trying to do the expenses as minimum as possible. So that's also an example for minimization of cost. That is an example for the optimization problem. That means either maximization or minimization of any particular object function is called as optimization problem or optimization. Okay, so coming to the optimization. So coming to the optimization, let's assume I want to share one thing. If we are working on any optimization problem for a particular client, suppose I'm the employee for a company and my company has a client, and my client gave one problem statement, some optimization related problem statement. So my client don't know any mathematics, just he will tell his requirement. So he will tell his requirement. So I have to note it down, or he will give his requirement as a text format. He will give his requirement as a text format, or he will give his requirement orally. I have to prepare it in the text format in my notes. I will note it down. Fine. Then we can't solve, if there is a problem in the text format, how will you solve it? It's not possible. We have to understand the problem carefully, and we have to convert into a mathematical modeling. So our problem is in the text format. Okay. And this problem will be converted into the mathematical modeling. Then we have to use some computer program to solve this problem. So this is the integration, right? So your client will give the information orally or in the text format. As an engineer, you have to convert into a mathematical modeling, and later you have to use some computer programming to get the solution. For example, I want to tell, you can see this one. Yeah. So I'm trying to explain the case study. So let's assume I am working for a software company, and my software company has a client. He's a chocolate manufacturer. Then he gave the problem statement like this. He gave his requirement like this. Like consider a chocolate manufacturing company that produces only two types of chocolates, like Dairy Milk, Cadbury, like this. They two types of chocolates they are manufacturing, A and B. Both chocolates requires milk and choco only. That means if you want to manufacture chocolate, some raw materials required, right? So let's assume the raw materials are milk and choco. Hope you understand. My client is a chocolate manufacturing company, and the company manufacturing two types of chocolates, A and B. And to manufacture those A and B type of chocolates, what required raw materials? Milk and choco. To manufacture each unit of A, that means 1 unit of A and 1 unit of B, to manufacture 1 unit of A and 1 unit of B, what are required? 1 unit of A required, 1 unit of A, if you want to manufacture 1 unit of A, required 1 unit of milk and 3 units of choco. For 1 unit of B, required 1 unit of milk and 2 units of choco. Whereas in the company, with my client, he has total 5 units of milk and 12 units of choco. He has the 5 units of milk and 12 units of choco. On each sale, the company makes a profit of 6 rupee per 1 piece of A chocolate and 5 rupee per 1 piece of B chocolate. Now the question is, we have to tell, as an engineer, I have to tell the solution. I have to give the solution to my client. How many number of A-type chocolates and B-type chocolates they have to produce so that they will get the maximum profit, so that they will get the maximum profit. Okay, so that they will get the maximum profit. So see, this is the text information. So what we have to do? So if you want to work on it, so first of all, we have to convert the text information into the mathematical modeling. Later, we have to use some computer program. Then we will get the solution. Done. So how we do the mathematical modeling for this one? How we do the mathematical modeling? So how we do the mathematical modeling? Now see this statement properly. See this statement properly. Now, so first you can, I think you are able to visible. You can see what is my objective. I am trying to maximize profit. So my client want to maximize his profit. How we can calculate the profit? You can go see the statement. Maximize the profit. So maximize profit. So profit, how we can calculate? For 1 unit of A, 6 rupee profit. 1 unit of B, 5 rupee profit. What solution I have to feed to my client? I have to tell how many units of A type chocolate, how many units of B type chocolate the company will manufacture or produce. I don't know, that I have to give. Okay. Let's assume X number of A type chocolate and Y number of B type chocolate. I want to give it as a solution. X number of A type chocolate, Y number of B type chocolate. We have to find X and Y actually. Our intention is we have to give how many number of A type chocolate, how many number of B type chocolate the company need to produce so that they will get the maximum profit. Okay. So let's assume this is the X number of A type chocolate and Y number of B type chocolate. We have to calculate X and Y. Okay. Then for 1 unit of A, how much profit we are getting? 6 rupee. And 1 unit of B, how much profit you are getting? 5 rupee. Right? Now what is the profit value? 6 rupee for A. So for 1 unit, 6 rupee. For X number of units, 6 into X. That is the profit. And plus profit is for both A and B, right? If the Y number of B type chocolate, for 1 unit of B type chocolate, how much profit we are getting? 5 rupee. For Y number of it is a 5 into Y. So this is the mathematical modeling. So I want to maximize this function, objective function. Right? Now it's not completed. It's just not compared to the mathematical modeling. Now again go back. This is over. Now for 1 unit of A requires 1 unit of milk and 3 units of choco. For 1 unit of B required 1 unit of milk and 2 units of choco. Right? Now suppose if it is X number of A type chocolate and Y number of B type chocolate, how many number of milk units are required? For 1 unit of A, 1 unit of milk. 1 unit of B, 1 unit of milk. So X units of A, X units of milk. Y units of B, Y units of milk. Because 1 unit of A, 1 unit of milk. X units of A, X units of milk. 1 unit of B, 1 unit of milk. And Y units of B, Y units of milk. Raw material is required. Small request. Done. Okay. So X plus Y. But you can see in my kitchen, my company, client company kitchen, he has only 5 units of milk. Only 5 units of milk. Then what I have to do? X plus Y. X units of milk to manufacture X units of A chocolate. Y units of milk to manufacture Y units of B type chocolate. So total milk unit should be less than or equal to 5 because my company has only 5 units of milk. And go to another one. Here, 1 unit of A required 3 units of choco. For X units of A, how many units of choco required? 3X. So see, 1 unit of A required 3 units of choco. Then for X units of A, how many chocos required? 3 into X. Plus, and for 1 unit of B, required 2 units of choco. Then Y units of B, how many units of choco required? 2 into Y. Now, this is about the milk units. This is about the choco units, milk units and choco units. Okay. Now, this is must be meant. See, my company, client company kitchen has how many number of chocos? 12 units of choco. You can see 12 units of choco are there. So what I can do? It should be less than or equal to 12. Right? And tell me, this X is nothing but the number of units of A. Y nothing but the number of units of B, right? So number of units of A chocolates, number of units of B chocolate, never be a negative number, right? We will not tell minus 2 units of A chocolate. Either not produce 0 or you produce 10, 20, 100, whatever it may be. So your X and Y values are, your X and Y values are should be greater than or equal to 0. Should be positive. 0 means don't produce such type of chocolates. If it is a 10, that means you have to produce 10 number of chocolates like this. So this is how we can build the mathematical modeling for your client's requirement. So you have to convert into the mathematical modeling as per your client's requirement. Okay. Now, hope you understand what I'm trying to convey here. So this is how we develop the mathematical model. So later, once the mathematical modeling is completed, then we will go to any computer programming to solve the problem. That we will move later. Okay. Now, if you observe this mathematical modeling, now we will discuss what are the different type of things available in an optimization problem. What are the different type of things available in an optimization problem? The first one is the thing what you want to do. Either you want to maximize or you want to minimize. You want to maximize the profit or you want to minimize the profit. Okay. And another thing you have, this is called as the what you are going to maximize. So this is called as what you are going to maximize or what you are going to minimize. So that is called as objective function. That is called as objective function. What you want to minimize or what you want to maximize. So that function is called as the objective function. Right? And your objective function is depending upon the few parameters, right? Your objective function, if you observe the mathematical modeling of your objective function, that is depending upon the few parameters. What are the parameters? What are the variables? The variables are called as the X and Y. Your objective function is depending upon your X and your Y values, right? So the variables which will decide the value of your objective function, so that is called as your decision variable. That is called as your decision variable. That is called as your decision variable or control variable, which will decide the objective function value. Right? So this X and Y is called as the decision variables or the control variables. Right? Now, what about this one? So this thing is called as, these equations are called as the constraints. So the equations are called as the constraints. These are the equations are called as the constraints. So what we are going to maximize, that equation is called as the objective function, and rest of these equations are called as the constraints. And your X and Y values are called as the decision variables. Decision variables. So hope you understand what I want to tell. Okay. Now, based on these things, so generally we will classify the optimization problem into the different categories. What are the categories? Your optimization problem is classified into two categories. One is called as the constrained optimization, and this is called as the unconstrained optimization. So optimization problems are classified into two categories. One is called as the constrained optimization and unconstrained optimization. Okay. So the name itself says that constrained optimization is nothing but if you convert your optimization problem into the mathematical modeling, in that mathematical modeling, you are able to see the constraint equations like this. If your mathematical modeling of your optimization problem consists constraint equations, so that is called as the constraint optimization problem. Actually, these constraints are again classified into two categories. One is called as the equality constraint. Another is called as the inequality constraints. The constraints are classified into two categories. One is called as the equality constraint, and another is called as the inequality constraint. Inequality constraints means here you have the less than or equal to, right? And the less than or equal to, right? So this is called as the inequality constraint. This is called as the inequality constraint. Whereas the equality constraint means you are able to see the only equality set. X plus y equal to 10, 3x plus 5y equal to 20. Like that with equality sign, in your constraints equation, if you see the equality sign, then it is called as the equality constraints. And in your constraint equation, if you see the less than or greater than, less than equal to or greater than equal to type of things, then it is called as the inequality constraints. Okay. Now, coming to the constraint optimization, I said that if you convert your optimization problem into the mathematical modeling, and if your mathematical modeling constrains the constraint equations, then it is called as a constraint optimization. Okay. And if you consider suppose if you convert your optimization problem into mathematical modeling, if you convert your optimization problem into mathematical modeling, and your mathematical modeling doesn't have any constraint equations, then such type of optimization problem is called as the unconstrained optimization problem. Such type of optimization problem is called as the unconstrained optimization problem. So these are the two types. And again, the constraint optimization problem is again classified into further two categories, like linear optimization problem, and another one is called as the non-linear optimization problem. Similarly, unconstrained also further classified into two categories, like linear optimization problem, and another is called a non-linear optimization problem. Okay, hope you understand. So what is the linear optimization? What is the non-linear optimization? So linear optimization problem means it's mainly depending upon your objective function. If the objective function is a linear function of your objective function is a linear function in terms of its decision variables, then it is called as a linear optimization problem. Then it is called a linear optimization problem. Linear means like this: no square term, no cube term, no sine square, no exponential. Only this is called the linear equation. 6x plus 5y. So my object function, profit object function is a linear function of decision variables x and y. So this is called as your linear optimization problem. Suppose if your object function is like minimize some x square plus x plus 10 like this, then we can call it as a non-linear optimization problem, because your object function is no more your linear function, because you have the non-linear terms like this. Okay, so if your object function is a linear in terms of the decision variables, then it is called a linear optimization problem. If your object function is a non-linear in terms of the decision variable, then it is called as the non-linear optimization problem. Again, if the objective function is linear and you have the constraint, then it's called as the constraints linear optimization problem. Your object function is linear, but you don't have any constraints, then it is called as the unconstrained linear optimization problem. Your object function is a non-linear and you have the constraints, then it's called as a constrained non-linear optimization problem. Right? And so for example, your object function is a non-linear, but you don't have any constraints, then it is called as a unconstrained non-linear optimization problem. So that's how we can classify the optimization problems. Like for example, I'm trying, so constrained linear optimization problem is, let's assume some maximize 7x plus 8y. So x plus y less than or equal to 10, 2x plus 5y equal to 20, like this. This is called the equality constraint. This is called inequality constraint. This is the object function. These are the decision variables. So this type of problem is called as the constraints, because constraint is there, linear object function, so it is a linear optimization. So this is the example for the constrained linear optimization problem. Suppose if your function is a minimize some x square plus y square plus 10, and you have some constraint like x plus y is equal to 20, x minus y is less than or equal to 10, like this, then it is called as a, because your object function is non-linear. So non-linear, I have a constraints, so constraint optimization. So this type of problems are called as the non-linear constraint optimization problem. And coming to here, what happened here? For example, here in this case, or the example for the linear unconstrained, suppose if you want to try maximize 7x plus 5y, no constraints, then it is called the unconstrained linear optimization problem. Suppose if you want to minimize or maximize, whatever it may be, don't tell that everything non-linear and take the minimization. No, you can apply maximization also. Either it is minimization or maximization. So something like x square plus y square plus 10, but no constraints here, then it is called as the unconstrained nonlinear optimization problem. So these are different type of optimization problem. Generally, in case of machine learning problems are comes under the unconstrained nonlinear optimization problem. We are come with in case of the machine learning, in case of the artificial intelligence, most of the problems, most of the algorithms are based on the, most of the problems are based on the unconstrained nonlinear optimization problem. Unconstrained nonlinear optimization problem. Right? So from this complete analysis, in a mathematical modeling of any optimization problem, in mathematical modeling of any optimization problem, what is the mandatory thing? What is the mandatory parameter, mandatory thing that must be available in a mathematical modeling of an optimization problem? That is mandatory. So what that mandatory? That is called your objective function is mandatory. Object function is mandatory. Without object function, what you will minimize or maximize? So in any optimization problem, our object function is a mandatory parameter, mandatory thing that must be exist. Otherwise, not a problem. Because if you have an object function, that object function we are trying to either maximize or minimize based on the requirement. If we don't have any object function, what we will do? Right? So for any optimization problem, the mandatory thing is a objective function. But the constraints are, for some problems, constraint exists, and some problems, constraint may not exist. So coming to this machine learning problem, most of the machine learning problems, we will not go with any constraints. It has only objective function. So that's why in case of the machine learning, artificial intelligence, or deep learning, whatever it may be, we required non-linear, unconstrained optimization problem solutions, methods we require. Okay. So I think we are clear with what mean by the optimization and what is the mathematical modeling of a optimization, what are the different parts or different things that is available in a mathematical modeling of an optimization problem, like objective function, decision variable, and the constraint, and what are the different type of the optimization problems, and which type of optimization problem is used in a machine learning. So that all we discussed here. Okay, hope you understand this phenomena. Okay, now for the next 30 minutes, I'm trying to focus on a linear optimization and its implementation. And post break or before break, we will discuss about the one of the optimization technique that is used to solve the unconstrained nonlinear optimization problem, that is called as the gradient. Many techniques are there, but we are discussing about the gradient descent method because this is used in the machine learning. So gradient decent algorithm or decent optimizer or decent method we are using. We are going to discuss about. So in case of the nonlinear, this part, I don't want to go with this one and I don't want to go with this one because this part is required for the machine learning aspect. That's why I'm trying to explain. So we are trying to work with some unconstrained nonlinear optimization problem. We will work, and how we will solve this type of problems using the gradient descent method we will discuss. Okay. Now, before going to this one, first we will focus on the linear optimization problem. Linear optimization problem. Again, go back to the same case study, manufacturing case study. So go with the same manufacturing case study. Chocolate manufacturing case study. So as usual, so based on this one, so my object function is maximize the profit. How we maximize the, so maximize profit, right? So maximize profit. So what how we develop the mathematical modeling for the profit? We know that 6 rupees profit for A, for 1 unit of A, 5 rupees of 5 rupees profit for 1 unit of B, right? Suppose let's assume X number and Y number, X number of A type chocolate and Y number of B type chocolate. Let's assume I want to calculate X and Y. Then what is the profit now? So what is the profit now? So profit equal to, so 6 rupees on A type chocolate, 1 A type chocolate. If X units of A type chocolate, total profit equal to 6 into X. Okay. And for 1 unit of B type chocolate, 5 rupees. That means 5 into Y. That's the profit. Okay. And coming to the constraints. So if you want to produce 1 unit of A, how much milk is required? 1 unit. If you want to produce 1 unit of B, how much milk is required? 1 unit. Suppose if you want to produce X number of A type units, Y number of B chocolates, then what the total milk is required? X plus Y, because 1 into X plus 1 into Y. But how many number of milk units are available in my kitchen? 5 units. So it is a less than or equal to 5. Don't go beyond 5. I have only 5 units, right? I have only 5 units, so that's it. And what about the Choco's case? For 1 unit of A, 3 units of Choco required. For 1 unit of B, 2 units of Choco required. For X units of A, 3X Choco. For Y units of B, 2Y Choco. So that means 3X plus 2Y should be less than or equal to how many number of Choco units are available? 12. Should be less than or equal to 12. And your number of milk units, number of chocolate units, sorry, number of A type chocolates, number of B type chocolates should be a positive. Should be a positive. So this is our mathematical modeling. That is our mathematical model. Okay. Now we will discuss about the programming. Now we will go to the computer program and we will discuss about how we solve this problem. And later I will share one new case study with you. So based on your interest, so at home you can try to solve that new problem. Try to solve that new problem. Okay. Now, first I am trying to implement this problem. I want to solve this problem using Python. I'm trying to solve using Python. Okay. Just a minute. Role of optimization. In this, I will create a folder, some class folder. Done. So now I'm trying to write the code. Okay. Okay. Now, generally, I will write this code using Visual Studio. File, open folder. So what the folder in my case, rule of optimization, class folder. So select. So here I want to write the code. So give the name like what we can give, like linear optimization, LO. Some name I'm giving with .py extension because it is a Python file. So I'm giving the with the .py extension, and I want to save this one. Okay. Now, what to do? How we will go is this approach? So we will discuss. So you can see. So actually, we have the different libraries. So we have the different libraries like from the SciPy optmatch, we have to import the linprog method. We need to import the linprog method. Okay, that means from from SciPy dot. It's the optimization problem, right? So optimize. So from this, what we are going to import the method called linprog. So linprog method is used to what's called to solve the linear optimization problems. To solve the linear optimization problem, this linprog method will be used. Sorry. Just a minute, please. Okay. Now, so later, now it's fine. So we have to import the method called linprog method. So linprog method is used to solve the linear programming problem. Okay. Later, so we need to import a few more libraries like math library and NumPy library. Of course, in this case, it's required. So math library, import math as empty means we are providing the alias name. So instead of calling math every time, instead of math, I can use empty. Similarly, NumPy library, that is the like if you are dealing with some arrays related thing, then we are using the NumPy library. I'm calling this NumPy library as NP. I'm calling this NumPy library as NP because it's like a alias name. Okay. Now what to do? So import math as empty and import NumPy library as NP. Now coming to our problem. Here maximize 6x plus 5y, right? So in the Python or in the MATLAB, the linear optimization problem was the solution for the backend code was developed for a minimization problem, not for the maximization problem. For a minimization problem, for a linear programming, they developed the code for the minimization only, not for the maximization. Then what we will do? So try to convert this maximize profit into the minimization problem. How we saw convert into minimization problem? Instead of maximization, so minimize minus profit. That means minus profit. So this minimization of the minus value means it's the maximization, right? So that's equal to minus 6x minus 5y. Why we need to convert into minimization problem? But the backend code for linprog method, either in the MATLAB or in the Python, which was developed for the minimization problem. Our problem actually maximization, we want to convert into minimization. So minimize minus profit means it maximize the profit. Minimize the negative value means maximize it. Positive value, right? Okay. That's why we have to convert into minimization problem, just simply multiplying the minus with minus to your objective function. Just simply multiply with your minus to your objective function. Then now see, now from this case, you have to write the coefficient matrix or object function matrix. So your object function matrix is equal to your coefficients. What are the coefficients here? -6 and -5. So this is because x coefficient is -6 and y coefficient is -5. So with that coefficient, you have to prepare the one objective matrix, OBJ matrix, whatever it may be. You can give any variable name. Okay. Now we will do that one. OBJ is equal to -6 comma -5. Done. Okay. Now, next what we have to do? Now we will work with the, so object function is we read the object function like this as a matrix form, because your computer will understand only numbers, right? So we have to feed it in the form of the numbers. So OBJ equal to -6 comma -5. Okay. Now coming to the constraints. So coming to the constraints, so see what happened. How we represent these constraints in the matrix form? We will represent the constraints in the matrix form. How we can represent? 1, 1, 3, 2. See carefully. 1, 1, 3, 2 multiplied with your variables, decimal variables, x and y. Then what you have? 1x plus 1y, x plus y. 3x plus 2y, 3x plus 2y, right? Less than or equal to your 5 constants, 5 and 12. Okay. So you can call this one as a your choice, what you want. So a inequality constraint matrix. So you may write it as a x matrix, variable matrix, and you can write this one as a b inequality constraint matrix. That means this matrix can be represented as a inequality constraints into variables equal to b inequality constraints. Now we have to feed these two matrices. Nothing but the matrix, coefficient matrix for the decision variables x and y. And 5 and 12 is the inequality constant matrix. 5 and 12 is the inequality constant values. I think it's clear. So what are the constants we have? We have to convert it to the matrix form. The coefficient matrix of the variables is the 1, 1, 3, 2. That is called A inequality. You can use any name here. Don't worry. You can use any name. You can use A, B also. If you have any doubt, you can call it as the A and you can call it as a B. Forget about all the things. So is called X less than or equal to B. So AX less than or equal to B. Now you have to feed this A matrix and you have to feed this B matrix in the Python. How? So found A equal to, your matrix is 1, 1, first row completed. Next is 3, 2, I think so. Yeah, 3, 2. Sorry, 3, 2. So A matrix is completed. Now B matrix equal to, what is the B value? 5 and 12. 5, 12. 5, 12. So you have to feed. That means I have given the different variable names. So forget about this one. I'm giving just I'm using LHS, left hand side of the inequality constraint, and RHS, right hand side of the inequality. So actually here power was disconnected. So we will start now. Now coming to the implementation of the code. Now see. So A value, B value, we entered here in the program. A value means coefficient matrix in inequality constraint. B is nothing but the constant matrix in the inequality constraint. If we convert our mathematical modeling as a AX less than or equal to B format. Okay, we have the A and B values. And what else we have to give? As per the problem, so as per the problem, we have the boundaries, right? So we have the boundaries. So what are the boundaries here? And that means we have the decision variables X and Y. So what the limit for the X? What are the lower limit? What are the upper limit for X and Y decision variables? That means you can write any variable B and D boundaries is equal to what are the boundaries here for X? What are the boundary? Minimum value 0 should be positive, and a maximum value maybe some number like a float number. So sorry, maximum value is up to infinity, any positive number, right? So INF infinity. Okay. And similarly for the Y, so 0 comma the float, sorry, float, so infinity. So is a positive number, right? So it is a positive number. Okay. So boundaries, this is for the X, and boundaries, this is for the Y boundaries. So X bound is positive, 0 to infinity, Y also positive, 0 to infinity. Okay. Now we will use our linprog method. So how the linprog method will be? So here we have the syntax for the linprog method. So how we use the linprog method, you can see this one. So what are the things are available, we can keep it there. Remaining things we can omit. So we no need to use this one. And X naught means initial value. There is no initial value here. We can use options if you want to use the different type of algorithms to solve this linear optimization problem. If you want to use the different type of algorithms, a specific algorithm to solve this linear optimization problem, you can use the options. So you can no need to use this callback, all things, boundaries. So what is the boundaries here? Bounds nothing but boundaries. So bounds nothing but the boundaries. What are the boundaries here? Boundaries is mentioned by B and D. Boundaries is mentioned by B and D. So B and D, that is the lower boundary and upper boundary of each variable. Please listen here. So bounds, nothing but the boundaries of your decision variables. So what are the boundaries of my decision variable for X? 0, positive, 0 to infinity. Y also 0 to infinity. Boundaries. And in my problem, do we have any equality constraint? This is the A equality, B equality. That means coefficient matrix of the equality constraint and constant matrix of the equality constraint. But in our problem, we don't have any equality constraints. So if what I want to tell you is, here we have the only inequality constraint, right? We have the only inequality constraint. So this is the inequality equation. If we have the, let us assume, if we have a equality constraint like if you have the equality constraint, then let us assume we have the equality constraint like x plus y is equal to 10 and 2x plus 3y equal to 20. Let us assume if we have, let us assume. In current problem, we don't have any equality constraint. We have the only inequality constraint. Suppose if we have the equality constraint, how the converted to matrix format? So it is the 1, 1, 2, and 3. And this will be the x and y. And the is equal, sorry, equality. This is equality constraint equal to 10 into 20. So this is called as the equality constraint, coefficient matrix of the equality constraint. And this is the decision variable X equal to this is the constant matrix B equaled. So this is called AEQ and the BEQ matrices. This is the BEQ matrix, this is the AEQ matrix, right? But whereas in our problem, we don't have any equality constant, right? So as we don't have any equality constant, you can omit this one also. You can omit A equivalent and B equivalent also. Done. Now what about the BUB and AUB? So BUB and AUB nothing but as per the method, Linfrog method, AUB and BUB nothing but the A means this one. This is the coefficient matrix of a inequality constraints. And BUB is nothing but the constant matrix of the inequality constraints. So what is the constant matrix of the inequality constant? Nothing but the B. So you can write B. And what about the coefficient matrix of the inequality constant? A. So in place of here AUB, you can feed the A. Right? We are feeding the boundaries of my decision variables. We are feeding the what's called inequality constraints, constant matrix and the coefficient matrix of the inequality constraints. There is no equality constant, just we are omitting that one. And what about the C? C is nothing but your objective function. So what is your objective function? So your objective is OBJ. So feed the OBJ. Okay. So remove this comment section. Remove this comment section. Now you can pass this to a variable called your choice. You can use any variable. Like I'm using here OPT. Here I'm using the OPT. So you can use whatever it may be. You can write. So OPT, the solution will be captured by this variable called OPT. Solution will be captured by this variable called OPT. Now, if you want to see the values, then you can use this command. Number of chocolates you want to produce. Number of chocolates you want to produce. So number of chocolates you want to produce, that chalk equal to np.round. Round means I want to round it off my solution. I'm trying to round it off my solution. That means if it is a 1.5, make it to 2. If it is a 2.3, make it to 2. So like that, to round off the solution. And so we have to pass OPT, this object, and X. Okay. And if you want to print this one, print. So you can write this statement directly. So print. So number of A type chocolates, number of B type chocolates, so you can pass here. The print statement you can type. That's it. So print number of A type chocolate. So I think someone C language, that's also fine here. So percentage, floating point up to 2 decimals, and the floating point up to 2 decimals. So in the chalk, it throws the 2 values because we have the 2 variables, right? X and Y. So it throws the 2 values. So 0 holds the first value and 1 holds the second value. So simply save this one and you can run this one. So I think you are able to see the solution. It is showing that number of A type chocolates equal to 2 and number of B type chocolates equal to 3. Number of A type chocolates equal to 2 and number of B type chocolates equal to 3. So like that, we can write the code in the Python to solve any linear optimization problem. So I want to tell once again, step by step here. So here, first line is about you have to import the method to solve the linear optimization problem. So from scipy.optimize import linprog method, you have to import because you want to use that method. That method means not a mathematical method, that is a computer program, computer function, backend Python function or Python library you have to call linprog. Of course, I think it's not required. In this case, that import math function is not required. I'm not using anywhere in the code. So you can omit that one. So import numpy as NP. So import numpy as NP. I am using that NP because to round off my values. To round off my values, I am using numpy. Okay. Now feed your objective function values. So if your objective function is a maximization problem, convert into minimization problem, simply multiply with the minus sign. And what are the coefficients? We have to feed it. So -6 and -5. If you trying to recap, you can see this one. Sorry. See, -6 and -5. Actually, profit maximization problem. I'm trying to convert into minimization problem. I multiply with minus sign. Then I have the -6 and -5. Now my matrix becomes -6, -5. And these values we need to feed. -6, -5. Next, form the coefficient matrix of your inequality constraints. So my inequality constant is x plus y, 3x plus 2y. So coefficient matrix is 1, 1, 3, 2. You can see 1, 1, 3, 2. Now, what about the constant 5, 12? So 5, 12. So you can give A, B, or your name also, you can give the variable. That's it. I'm using capital A for the coefficients and small b for the constants of a inequality constraints. Okay. Next, what next we have to do? There is no equality constraints. So we can omit. Now, what about that? X and Y. In the mathematical modeling, if you observe in the mathematical modeling, we are rating X, Y should be positive, greater than or equal to 0. So your X and Y value should be greater than or equal to 0. Greater than or equal to means it's a positive number, anywhere up to infinity. So that's why B and D, that is a variable. You can use any variable here. So this is for your X. Minimum value 0, maximum value floating point, infinity. And here, minimum value 0, maximum value infinity for Y. So if you have another variable, you have to keep it comma and write another variable. For another variable also, you can write what's called 0 and infinity like this. After that, now call your linear programming what you imported in the first line. Okay. So OPT, there is a variable that holds the returns given by your linprog method. Linprog method returns some values, right? Solution, that will return solution. That solution means how many number of A type chocolate, how many number B type chocolate. That values will be held by OPT variable. You can use any name there. Left hand side of the equality sign is a variable name. It is user defined. We can use any variable name. Opt. So now linprog method I am calling. C means cost function, nothing but object function. So object function is nothing but the -6, -5. AUB, it represents the coefficient matrix of the inequality constraint. What is the coefficient matrix of the inequality constraint? A. So SNA. BUB means constant matrix of the inequality constraint. What is the constant matrix? B. So B assigned. And bounds, nothing but what are the boundaries of your variables. So those values are held by B and D. So assign that one. Okay. Now from this opt variable, capture that solution using opt.x. It throw multiple values like exit flag and output, different descriptions it will throw, but we don't want all, only we want the solution. That means how many number of A type chocolate, how many number of B type chocolate, that is required. So this command, because I am using the OPT here, you have to use OPT here. If I use something else here, you have to use something else here. If I'm using Ramana, then I have to use Ramana.x. If I use something something other name, so you have to use that name .x. And I'm trying to round it off to get the pure integer value. So finally, I'm trying to print that information. Why we are using the 0 and 1? Because my chalk variable has the two values. One is the number of A type chocolate, another is the number of B type chocolate. First value holds with the 0 index. Second value holds with the first index in the Python. And third, if there is a third value, that will be in the second index. Because I have the only two values. So one is the 0 and another is the 1, like that. So simply run this one like this, and you will get the solution 2.0 and 3.0 like this. Okay. So this is about the that implementation, solving the linear optimization problem using Python, using linprog method in Python. Okay. So hope you understand what I want to, what I'm saying here. Okay. Now, actually, here I am using the Visual Studio code ID to run Python code. This is the Visual Studio code ID to run the Python code. This is what I am using now. For suppose, if any Python ID is not installed in your computer, suppose if any Python IDE is not installed in your computer, then what you will do is, we have a free platform that is called Google Cloud. Google Colab. So we can use the Google Colab to write the Python code. Suppose in your local machine, if you have a Python IDE, you can use the Python IDE and write this code to solve the problem, optimization problem. Suppose if your computer don't have any Python IDE, then go to the Google Colab and solve it. You can use the Google Colab also. Okay. Now I'm trying to write the same Python code in the Google Colab. This is the cloud platform. So only if you have the Gmail account, that is sufficient. Suppose if you have the Gmail account, that is sufficient. It will work. Okay. It's a cloud platform. Suppose if you forget your computer, if you are somewhere else, and if you open someone's computer, connect to the Google Colab, then you can access your code once again. It's stored in the cloud only. Now I am trying to explain how we will use the Google Colab to write this same Python code. Okay. So right. I am trying to use Google Colab. So welcome to. So once you type Google Colab in the Google browser, we are able to see welcome to Colab. Welcome to Colab. Just click on this welcome to Colab Google. It'll ask my previous all the things it is asking. So just click on the new notebook. Click on the new notebook. So if it is pop-up is coming like this, click on the new notebook. Otherwise, go to file and select the new notebook. So click on the new notebook. Click on the new notebook. So this is your Colab thing. This is your Colab thing. It is a Jupyter notebook. This is called a Jupyter notebook. And this is called the cell. In this cell, we have to write the code. In this cell, we need to write the code. Okay. Now first save this file. So what you want, you can use that name. So linear optimization. So just I'm writing linear optimization. Now same code we can use it here. So what is the code? First step. What is the first step? Import linkprog method. So from scipy dot optimize import linkprog method. Then what next? So import numpy as np. Okay. So numpy to make it round of things, and np is called as the alias name. Whenever you want to use the numpy method, you can use np instead of numpy. What next? Feed the objective function matrix. Or the objective function matrix -6 comma minus I think 5. -6 comma -5. Next, coefficient matrix of the inequality constraint. So a equal to, what is that one? One is the 1 comma 1. So if I'm wrong, please let me know. And there is a, I don't know, 2 comma 3. I forgot where it is.
3 comma 2.
3 comma 2, sir.
3 comma 2. 3 comma 2, right? So it is a 3 comma 2. A. And what about the B matrix? That means a constant matrix of inequality constraint. So what is the B matrix here? I think it is a 5 comma 12.
5 comma 12, sir.
5 comma 12. Thank you. 5 comma 12. So next we don't have, actually, if we have the equality constraint, we have to write that matrix also. For example, suppose these two equality constraints exist. If these two equality constraints exist, then you can write 1, 1, 2, 3 and 10, 20, right? You can write like a equality constant equal to 1 comma 1 and second row equal to 2 comma 3 and constant matrix of the equality constant equal to maybe 10 comma 20. Like this we can write. But in our problem, we don't have these equality constraints. So no need to write that one. Now we have to use the boundaries. B and D equal to. So what are the boundaries? It is a positive. So positive 0, comma, FLOAT. So actually INF, it is a string. It is called typecasting. I want to convert into a number. So that's why float. Is there the string you have to call INF, infinity. And what about the Y case? Y case also 0, comma. So maximum value is infinity. Maximum value is infinity. So these are the boundaries. These are the boundaries. So okay, I will share this code. This is the boundaries. So what next? So you have to use any variable OPT. You can use your name also. OPT equal to linprog method. Call the method. So what it is expecting? It is expecting the cost function, nothing but object function. So cost function C equal to your object OBJ, comma, and it is expecting coefficient matrix of the inequality constant. I think A underscore UB, right? Yeah, A underscore UB. So what is the coefficient matrix of the inequality constant? A. And what is the B underscore UB? That means constant matrix of the inequality constant. Constant matrix of the inequality constant. So that's equal to constant matrix of the inequality constant. That's equal to small b. That's it. We are and boundaries also there. Boundaries also there. So comma boundaries bounds boundaries equal to b and d. That's it. We are feeding. So if you want any method, specific method, you can call that method also. For example, you can see here. You can use the method. So this is the method. So you can use the method like this. So method equal to highest decimal is, it is called dual simplex method. And if you want the simple method within the code, you have to pass the simplex. If you want the interior point method, you have to pass interior. Okay, otherwise I will use this one also for your easy understanding. So comma. So what it means? So method equal to which optimization algorithm or which optimization technique you want to use to solve this linear optimization problem. To solve this linear optimization problem. Here ISDS means it is the highest dual simplex method. Or if you want to use the simplex method, copy and paste here. Or if you want the interior point method, copy and paste here. What method you want, you can use that one. If you want the interior point method, so Control C and Control V. So which method you want to use, you can use that one. So by default, it is used as the simplex method. If you're not passing this whole parameter, also no issue. If you're not passing the whole parameter, also no issue. By default, it will take the simplex method. Okay. If it create any disturbance, simply omit this one. Otherwise, you can use your choice. Okay. So that's it. Now, once the method we are calling is completed, now we need the solution. We want to read the solution. Chacos, number of Chacos. CHACO Chaco equal to np.round round off. So your solution will be available op.x. That actually linprog method will throw the multiple values. All the multiple values are available here. So now op.x, that means the solution will be captured. I want to capture the only solution. X values, nothing but the number of chocolates, number of the decimal variable values I want. So opt.x. This dot x is don't change. You can change opt. If you use here Ramana, you can use here Ramana.x. If you use v here, you can use v.x here. But dot x is important. Okay, Chacos. Now if you want to print, so print. So you can use Chaco, or you can write some statement. Number of A type chocolates equal to number of B type chocolates equal to also you can write. For example, what I want to say, number of A chocolates equal to percentage 0.2F, comma, choco, pass 0. That actually here we have the two decimal variables, right? X and Y. So X will be, the X variables don't confuse with this one. So it has the two decimal variables. One is the A type chocolate, number of A type chocolate, number of B type chocolate. Number of A type chocolate is stored in the 0th location. number of B type chocolates stored in the one location. If it is another variable, then that is stored in the two location, like that. So based on the location, we have to extract that value. So here A type chocolates will be available in the 0th location. And similarly, you can use B type chocolates also. Number of B type chocolates is equal available in the one location, because we have the two variables. One variable value stored in the 0th index, and the variable value will be stored in the index 1. Okay. So if you want to execute this code, so you are able to see a arrow mark on the right side. Just click on that one. Just click on that one. It will give the value. See, number of A type chocolates equal to 2, number of B type chocolates equal to 3. So like that, so you can use the Google Colab also to write the Python code. It will, so if you have a GitHub account, so go and save this whole file in your GitHub also. And you can save this copy, automatically it will save a copy in the drive also. So whenever you want, you can reback that file again. Go to Google Colab and open this file from your drive. A copy will be stored in your Google Drive also. So I think it's clear how we are what's called using Python, how we can solve the linear optimization problem. How we are solving the linear optimization problem. Okay. So I think some people are asking for this code. So I will copy this one, and I want to share with you through our WhatsApp group. So mostly it will work for you. So you can use, because I will give another exercise for you. So you have to work on that case study and try to solve that problem using Python programming as well as the MATLAB. So now we will discuss about the uses of the Python to solve the linear optimization problem, and also uses of the what's called Google Colab, using Google Colab. Also how we solve this linear optimization problem also we discussed, right? Now I'm trying to explain how we can solve the linear optimization problem using the MATLAB. Almost both are same, looks almost similar. Okay, now see. So I'm trying to open the MATLAB. So I'm trying to open the MATLAB. Just wait few seconds. It's opening now. So I think it's not opening, right? Okay. I will change the permissions. So someone trying to access that Jupyter file, what I shared with you, Google Colab file, but they are unable to edit it, I think so. At least you are visible. Is it visible? I think a few people like I am Sanja. Raghavan 14 and AB24 WRLR04. Some people are trying to access that one. If it is visible, I'm happy. You can open your Colab and try to by seeing that no code, and you can type it again. Okay. Now we try to work with the MATLAB. Okay. Now see, I want to open a new file, new editor file. I'm trying to use a command called CLC. It will not do anything to your linear optimization problem. Just it will clear the command window. Clear screen, it will clear your command window. If any information is available in the command window, that will be cleared, CLC. And clear all previous variables. It will not do anything related to your optimization problem. Just generally, when I'm writing the code, I'm using these two commands by default. Whatever the command window is there, it will be cleared. And whatever the previous variables are stored, that also cleared. Just generally I'm following. So, but now tell me, same concept, same thing. So what we are going to do? We have to read the objective function. obj equal to. So what is the objective? So -6. In Python, we are giving the comma, but this time you have to give the semicolon. -6 comma -5. So terminate every line with semicolon in the MATLAB. Otherwise, that will be printed in the command window. We don't want to see the output of the every line. I want to see the final output. That's why I'm terminating the every line with the semicolon. Next. What next? We are feeding the A matrix. A matrix means, what is the A matrix? Coefficient matrix. What is the coefficient matrix? 1 space 1. First row. Slightly change in the Python and MATLAB. In Python, we have to keep these two also in another square bracket. Now it's not required. So 1 comma 1 comma 3 and 12. So 1 1 first row, 3 2 second row, semicolon. And what about the constant matrix B equal to 5? There we are using the comma 12. Now we are using the semicolon 12. Close. That's it. Okay. See, semicolon and 12. Right? Now, coming to here, next, coming to the boundaries in Python, boundaries, both lower boundary and upper boundary are feeding with a single variable. B and D equal to 0 comma float infinity, 0 comma float infinity. We are passing the lower limit, upper limit of the both variables as a single variable. But here in MATLAB, we have to pass as a two different variables. Maybe like what's called LB. LB means lower boundary. So lower boundaries are, what are the lower boundaries? Both 0 comma 0. Lower boundaries are 0 comma 0. What about the upper boundaries? Infinity comma infinity. That's it. So we are passing the lower boundary and upper boundary. I think all the parameters were passed. We passed the object function. We passed the coefficient matrix and constant matrix of inequality constants, and we are passing the lower boundaries, lower values and upper values. Because it's a positive, x value minimum value 0, maximum value infinity, y value minimum 0, maximum infinity. In between, we will get some solution. Okay. Now, call your method. That's it. And one more thing, you have to use the options. So what is options? I will tell. So I will copy this complete thing. Options equal to optimization, options, linear programming algorithm. Here you have to pass which method you want to use. Here you have to pass which method you want to use. You want to use interior point legacy, or dual simplex. By default, it is a simplex method. Again, what method you want to use, you have to pass that one. Okay. Of course, it is an optional. This line is optional. If you want to specify a particular algorithm or particular method or particular technique you want to use to solve the linear optimization problem, then you need to use this 8th line. You have to feed which algorithm, which method you want to pass. You have to pass that one. And later you have to pass this part to next part. See. Now I'm taking the linprog method. Linprog. Same as Python. In MATLAB also we have the linprog function or linprog method. So in the linprog method, you have to pass your objective function. You have to pass you no need to give, previously we were giving the C equal to like that, right? So here no need to give. The first parameter, it considered it as a cost function. Second one, it will consider the constant matrix of the inequality constraint. And this one is considered as first this one, this location. Second location can be considered as a coefficient matrix of the inequality constraint. Third location, this location will be considered as a what's called a constant matrix of an inequality constraint. And this is called lower boundary. This location is for the coefficient matrix for the equality constraint. This location is for the constant matrix of the equality constraint. And here lower boundaries and here upper boundaries. Once again, I will repeat. In prog method, what values you have to feed? First, you have to feed your object function matrix, and you have to feed your constant matrix of your inequality constraint. Next, you have to pass, Second location is you have to pass coefficient matrix of inequality constraint. Third location is constant matrix of the inequality constraint. Fourth location is coefficient matrix of the equality constraint, but I don't have any equality constraint, right? Simply blank. And next location is constant matrix of the equality constraint. I don't have equality constraint, simply empty. Otherwise, you have to feed those values. And next one is the lower boundary. Next one is the upper boundary. Okay. And if you want to use a specific algorithm, then here, comma, you have to use these options. You can use these options. It is optional. I said right earlier, this line is optional for you. If you want to change the default to the simplex method, if you want to use some other technique to solve your linear optimization problem, then you have to use this 8th line. In the 8th line, you have to mention which method you want to use. Interior point Legendre, interior point, or dual simplex or simplex. You don't want to mention anything, just omit this 8th line, then ignore these options. Okay. So if you have any confusion, just remove this one and remove this one. That's it. That's enough. Now this linprog method will return multiple values. As I said earlier, it will return multiple values. One value is captured, that one, it will return multiple. And the first thing is it will throw the decision variable values. That means number of A-type chocolate, number of B-type chocolate, decision variable values, number of A-type chocolate and number of B-type chocolate. Right? Now, those values will be stored in the first location here. And what's the value? What is the objective function value? What is the final optimum solution value? Not variable values, function value, object function value, 6x plus 5y or whatever, 6x plus 5y. That value will be stored in the second location. Exit flag. So there's different flags it will be throws, whether the code is converged properly or not. So that flag will be captured here. Output. So it will give some description about the solution, which method they are used and what is the solution. All the things will be given in the output. So among all, you have to feed at least one that will capture. Now, so I want to save this code. Linear programming 1 class, any variable you can write. Something variable I'm giving here. Now try to run this code. It's showing some error. So B. A must be same as I think the problem is actually we have to feed it as a matrix, right? How we can represent the matrix? How we can represent the matrix? Our constant matrix 1 1 3 2. It is a 2 by 2 matrix. It is a 2 by 2 matrix, right? How we represent the 2 by 2 matrix? See, A equal to our first row is 1 space 1. The row is completed. We need to insert semicolon, not comma. Here I can incorporate the comma, not comma. It is semicolon. And another is the 3 space 2. Close this bracket and enter. You will get the values A and B. here. So instead of comma, you have to keep semicolon. Now run this code. Yes, optimal solution found. Now what is the solution? Right? So as else solve, then it will give the 2 and 3. Same value. Whether you are using the Python or you are using the MATLAB, but final solution should be same, right? Your solution is 2 and 3. Your solution is 2 and 3. Okay. Hope you understand, right? So that's how. So we are using the MATLAB to solve the optimization problem. Very simple. Just very few lines of code. If you have equality constraint, you have to write AEQ value also here. As of now, empty. You can write BEQ also. That means constant matrix of the equality constant. That also empty. So you can feed here because these two are empty, right? You can feed AEQ, and here you can write BEQ. So because AEQ, BEQ, so solution this. So these are 2 and 3. So this line of code is can be used to solve any I'm telling, any type of optimization problem. Any optimization problem, it contains 100 number of variables also. You can use this one. Actually, maybe some faculty may know about we have a concept called game theory. So game theory means we have the different game theory concepts like a core concept, nucleus theory, proportional nucleus theory. In the game theory concepts, we need to, inside the program, we need to solve the linear optimization problem also. So to solve that linear optimization problem, you need to incorporate with small changes, you need to incorporate this piece of code. Okay. So this is how we can use the MATLAB to solve the linear optimization problem. So I think you are clear with the linear optimization problem and how we can solve this linear optimization problem using the Python and using the MATLAB using the linprog method. Okay. So, and I will share this piece of code also if required. So it may be useful for practice. So I want to share this code also in our group. If required, you can use this for the MATLAB code, and Google Colab link is for the Python code. Okay. So this is how we can solve the linear optimization problem. Any linear optimization problem. This is only one case study I'm giving, and I want to give the another case study for your exercise. You can do it at home also later. So I will give this assignment, like an assignment. You can work on it. So try to analyze the problem and try to solve using both Python and try for the multiple program. Nothing will be happening, right? So try to solve this case study using Python and also using MATLAB. Okay. So you can do it later. It's okay. So this is all about the solving the linear optimization problem. Okay. Now we will discuss about the non-linear optimization. Okay. So that is very important. So that is very important for our machine learning perspective. Okay, machine learning perspective. Now we will discuss that. Okay. I'm trying to explain this non-linear optimization and solving the non-linear optimization method using the gradient descent method. We will discuss today. We have 1 hour left. So I will explain that non-linear optimization using the gradient descent algorithm. Listen carefully. Same thing I'm applying in the machine learning. So then we will get how these optimization techniques are useful. How these optimization techniques are useful in the machine learning. Then you are able to understand. Okay. Done. Okay. See, now we will work with non-linear optimization using gradient descent method. So I'm trying to explain this method with a very, very, very small problem because we need to understand. So once you understand, you can apply for any type of problems. But small problem, actually for the problem, what I'm trying to give as a case study, you no need to run, you need to write the code also. By seeing the function, we can know what is the object function value. final minimum value. But anyhow, please check. So I want to minimize a function f of x equal to x square plus 5. I want to minimize a function f of x equal to x square plus 5, for example. Let it. But to solve this optimization problem, I'm trying to minimize. I'm trying to minimize a function called f of x. So that means I want to identify the value of x at which my function will be minimum. Right? To get the answer for this problem, do we require a computer programming? Do we require a big algorithm? By directly seeing that function, we know that at x equal to 0, the value will be minimum. But why I am giving that a small example is, I said earlier, if you understand some algorithm, it's better to start with a small problem. Then we can apply the same thing to any. Right? Fine. Now see how this function will be. Now see how this function will be. So in the y-axis, it is the function f of x. And in the x-axis, it is the function x. So x is called a set space. X is the destined variable. X is the destined variable. F of x I am trying to minimize. F of x I am trying to minimize. X is the destined variable. My object function is depending upon a variable called x. And that's why x is called as the destined variable. X is called as the destined variable. Okay, good. So x set space is varying from the minus infinity to plus infinity. Anywhere, your solution, optimal solution, anywhere in the set space from the minus infinity to plus infinity, we don't know. Anywhere in this case. Now see how this function will be. If you draw the diagram, how this function will be. It is x equal to 0. At x equal to 0, what the value of the function? X equal to 0, value of the function equal to 5. The value of the function equal to, I will use some other color. So x equal to 0, the value of the function equal to 5, right? When x value is increasing toward the positive axis, if the x value is increasing toward the positive axis, x value is increasing toward the positive axis, then what happened? X square value increases. So your object function increases. So your object function value will be increasing like this. Okay. If the x value is increasing toward the negative axis, -1, -2, -3, -4, -5, like that, towards the negative side, then what happened to this object function? -1 whole square, 1 plus 5, 6. -2 whole square, 4 plus 5, 9. So it is also again increasing. So if it is moving the negative x-axis, then it is also again increasing. It is also again increasing. So this is how your object function will be. That is how your object function will be. And this type of function is called as the convex function. And I think you agree, this is a non-linear function. Linear means a line, but it is a non-linear. It is like a curve. It is a non-linear function. Right? Hope. So this is the non-linear function. My object function is a non-linear. So I am in the non-linear optimization. No constraints. So non-linear, unconstrained optimization problem. This type of optimization problem appeared in the machine learning. That's why I'm taking this example. Non-linear, because it's a non-linear function. You can see here, it is a non-linear function. Okay. And no constraint, unconstrained optimization. So non-linear, unconstrained optimization. Why is the optimization? I am trying to minimize a particular object function. So it is the optimization. My object function is a non-linear. My object function is non-linear. So that is a non-linear optimization problem. Non-linear optimization problem. And no constraints. So it is a non-linear, unconstrained optimization problem. Okay. So that's it. Fine. Now, how we solve this one? We know that at x equal to 0, because it's a very simple function I have considered, we know that at x equal to 0, my function will be minimum, and the minimum value of the function equal to 5. We know. Right? But how we solve? But in the complex problems, in the machine learning, it is very difficult to visualize. It's not difficult to identify your optimal solution by seeing the equation. Then we require this iterative gradient descent approach. But to understand this iterative gradient descent approach, I am taking a very small example where we know the optimal solution also. Where we know the optimal solution also. I think you are clear with what I'm saying. So before going to the algorithm, I want to tell one thing. For example, there is a, let us assume this is the f of x. And this is the x, let us assume. And this is some line. And this is the y-intercept. Then how we represent this line? F of x equal to some slope m, let us assume m into x plus c. That's how we can represent the line. So in this case, m is called as the slope. This m is called as the slope. Now, if you want to get the slope from this equation, then what we can do? Simply differentiate your function with respect to the variable. Then what happened? Dou f by dou x. So dou f by dou x equal to m. That's nothing but your slope. So if you trying to do the first order differentiation, or if you're trying to calculate the gradient, so that will give the slope. I think you agree. So if you find the first order differentiator or gradient, then it will give the slope value. In other case, one more thing I want to tell. Let's assume what will be the slope of this line. Let's assume this is the f of x and this value will be the x. So what is the slope of this line? Let's assume this is intercepting at 5. Let's assume at 5. Then what is the equation? First, what is the slope of this equation? Okay, forget about the slope of the equation. How we represent this line? We represent this line as f of x equal to 5. F of x equal to 5. Now, if I want the slope, what you can do? First order differentiation. So dou f by dou x equal to what the for a differentiation of a constant? 0. So if there is a line parallel to the x-axis or different variable axis, slope equal to 0, we know. So finally, first order differentiation also we are getting the 0. That means, so if you want to calculate the slope at any point, it's better to calculate the first order differentiation or the gradient to get the slope. So now I think you are clear with this thing, what I want to convey. If you want to calculate the slope at any point, it's better to calculate the first order differentiation or the gradient of that curve of that equation with respect to the given variable. Done. Fine. Now coming to our nonlinear optimization problem. Carefully observe here. This is my objective function. This objective function is minimum at some point of x in the complete set space. Where it will be minimum, I don't know, because it's a small problem, I'm able to visualize. Because it is a small problem, I'm able to visualize. But in the larger problems, in the real-time problems, you can't visualize it. Somewhere in the set space, your function will be minimum. We don't know where it is. Then what we will do? We need to start from any one initial point, right? For example, let us assume I am working as some health worker in an hospital, and my supervisor instructs me go to particular village and collect the samples of all the people and check whether any person has a COVID-like symptoms or not, like that they asked. Then what I will do? So to search for the COVID affected people, I am starting from some random point, some random village, random house, random people in that village, randomly. Here also, in the complete set space, if you want to identify at what point your function will be minimum, we don't know. So you have to randomly start from any one point. So let's assume I am considering my random point somewhere here. Let's assume. Okay. Now, and one thing I want to tell, if you want to calculate the slope at this point, nothing but the tangent. So slope of this tangent is nothing but the slope at this point. Okay. This is my optimal solution, right? So at the optimal solution, my tangent will be like this. At optimal point, my tangent will be like this. I choose a random point, then my tangent will be like this. So at the optimal point, at the global optimal point, what is the slope? at the global optimal point, what is the slope? That means the tangent line is parallel to my descent variable axis, H space. So when a line is parallel to my descent variable, then what about the slope? 0. So at this point, slope equal to 0. Okay, at a global, it's called a global because my object function has only one optimal point, global optimal point. At the global optimal point, slope equal to 0. My intention is I want to go to that global optimal point. I want to go for the global optimal point. Okay. So to reach this point, I don't know where this point will be. I don't know where in a complete object function in the complete set space, at what point my object function will be, value will be low. At what point my object function has a slope 0. I don't know. So just I'm starting from the random point. At this random point, I am calculating the slope. So how we calculate the slope? Simply calculate the first order differentiation at that point. First order differentiation at that point, that will give the slope. That will give the slope. Okay. So if it is a slope, then what we will do? If the, let us assume it is a positive slope, let us assume. Okay. For example, suppose your initial point is not here. Let us assume your initial point is not here. Your initial point is somewhere here, let us assume. Your initial point is somewhere here. If the initial point is here, then what is the tangent slope here? So your tangent slope will be like this. So here it is a positive slope and here it is a negative slope. You can try. You can try for the tan 60 and tan 120. So you will get 120 side, you have the negative value, 60 side, you have the positive value. Okay, so this is the your positive slope. Here it is the negative slope. So what I can do? Suppose if my initial point has a positive slope, try to move this one toward the negative slope. If my initial point is in the positive slope, try to update to or try to move this point towards the negative slope. That means what happened? Then my point will be moved toward the negative slope side, toward the negative slope side, toward the negative slope side, and finally reach this point where my slope equal to 0. That's what our intention. We want to reach the, we want to update our point, update our variable value in such that it will reach the slope 0 point or optimal point. Slope 0 point or optimal point. So maybe we have a doubt, sir, every time we are getting a point on the positive slope side. No, it may be negative slope side. Suppose if your point is in the negative slope side, if your point is in the negative slope side, then try to move your point toward the positive slope side. So try to move your point toward the positive slope side, and finally it lands in the point where the slope equal to 0. Where the slope equal to 0. Hope you understand how it will, how we are searching for an optimal solution, how we are searching for a optimal solution in the search space. That's how it's called gradient descent algorithm, because it's based on the gradient. Where we are using the gradient, this is called as the gradient. Gradient or first order differentiation or slope. So here we are calculating the gradient or first order differentiation or slope, whatever it may be. Okay, hope you understand what I mean to tell. Okay, just a minute, please. Okay. Okay, so hope you understand how, so what the steps I am following. If you observe what are the steps I am following, you can observe carefully here. So if you want to solve any nonlinear unconstrained optimization problem, I have to choose a random point in the set space. I have to choose a random point in the set space. What I did next? I have to calculate the gradient at that point. What next? Now update the point in such a way that if the point is in the negative slope side, it should move in the if the point is in the positive slope side, it should move to the negative slope side. If the point in the negative slope side, it should move toward the positive slope side. Like that, we are going to update your point. This process will be repeated. This process will be repeated until you are reaching this gradient 0 point or slope 0 point. Okay, na? So hope it's a clear for you. Okay, na? Now I'm trying to hope you understand, right? How I am searching this bottom point or global optimal point where slope equal to 0. How a point will be updated, right? Now I am trying to explain the pseudocode or algorithm, step-by-step algorithm I will explain. Okay, na? So now go back. Gradient descent algorithm I'm trying to explain. Otherwise, I will explain here only. It's not possible. No? We'll see. I will try to explain the algorithm here only. So tell me what is the first step? Step 1. Randomly initialize a decision variable value. Randomly initialize decision variable value. Okay. So what is the step 2? Step 2, what is the step 2? Calculate gradient at that point. At that point means at that value. That means what the, random initialize decision variable value, right? Whatever the value you are choosing, at what value you are randomly initialized, at that point you have to calculate the gradient. How we calculate the gradient? Dou f by your variable, dou f by dou x or dou f by dou y, whatever it may be. Calculate the gradient. What next? What next? So we have to decide in which direction you have to move. See, initially my point is here, right? So from here, I want to move toward the negative slope side. If my initial point is this one, from here, I am trying to move toward the positive slope side. And how much length I have to take care, how much step length I have to take. This is called as the step length. How much step length I am considered. That also we have to calculate. So if you want to update your variable value, if you want to update your decision variable value in the iterative process, you have to think of two. One is in which direction, at what length. Okay. If you want to go step length from initial point to next point, if you want to go step length, in which direction you have to move, how much length you have to go. That's important. Okay. So for that one, so I am writing, let us assume delta x equal to, because delta x is nothing but step length. X value, how much step it will take. Initial value is x. And how much step length it will take. Let us assume delta x value. That includes 2 points. One is the direction, another is the length. How we find the direction? We calculate the gradient, right? Dou f by dou x and should be multiplied with minus sign. Why minus sign? If the slope is positive, negative side moves. If the slope is negative, positive side moves. That's right. How we update the variable point? See, the slope is a negative value, negative into negative, positive. Your point will be moved toward the positive slope side. If the slope is positive, positive into negative, negative. That means your slope should be moved in the negative slope side. Right? So that's it. So that is the direction. And you have one more parameter that is called as eta. So eta is called as the learning rate. So eta is called as the learning rate that will decide how much step length it will take. How much step length it will take. So this minus dou f by dou x value, direction, eta value, that's called learning rate, how much step length it will take, how much update it will take, that will consider. Okay, na? So let's assume initial value is x equal to x naught. So you have to calculate the gradient at x equal to x naught. With that gradient, you have to calculate the delta x value. X equal to x naught. You have to calculate the delta x value. Please follow the steps. And the same concept we are using the machine learning also. And we will try to solve this one. Later we will discuss. Okay. Next, once we calculate the step length, we calculate the step length. So once you calculate the step length, what we have to do? Step 4. What we have to do? We have to update our x value. So initially at this point, and we calculate the step length. Now update our point. So how we update our point? Step 4 equal to x plus delta x. X equal to X plus delta X. Okay. So these 4 steps, step number 2, step number 3, step number 4, these 4 steps are iteratively it will work. Iteratively, multiple times, these 3 steps will work until your slope equal to 0 generally, but we will not go for slope equal to 0 in the machine learning. We will use one convergence parameter that is called maximum number of iterations. Initially, we have to set how many maximum number of iterations you want to run this algorithm. You have to give the value 100, 1000, 10,000, whatever it may be. How many number of iterations you want to run this algorithm, that you have to specify. Those many times, these step 2, 3, 4 will be repeated. Step 2, 3, 4 will be repeated. So maximum number of iterations is one of the convergence criteria generally used in the machine learning. That's why I am using the same criteria in this case also. But in the because there is a small problem, I can use the convergence criteria such that once my slope equal to 0, slope equal to 0 means where it will be. My slope equal to 0 means this is the local point, final global optimal point. Reach. So I can stop the algorithm. Hope you understand. So this process, initially here, we are here, updated, and up to what instant we are going to update until we reach this optimal solution where slope equal to 0. So once the slope equal to 0, you can stop the iterative algorithm. But the same, because it is a very small problem, you can set a convergence criteria such that once the slope equal to 0, stop the iterative algorithm. But in case of the machine learning, that won't work well. That won't work well because you will not get the exact 0 point every time in the machine learning. So in the machine learning also, you will not get the exact values. It's estimated values. The stochastic approach, it's the estimated value, not exact value. That's why don't keep the error equal to 0, slope equal to 0 like that convergence criteria. Then it will not converge at any time. It will run like that. So it is a estimation. It will try to estimate, try to predict a closer value, not exact value. And moreover, I want to tell one more thing. Okay, anyhow, hope you understand this algorithm. So these steps, step 2, step 3, step 4 should be repeated until your maximum number of iterations are reached. Until your maximum number of iterations are reached. Right? So this is the gradient descent algorithm which is used to solve the nonlinear optimization problem without any constraints. This is the approach are used in the machine learning and deep learning also. Looks very three, but same fashion. But in case of the machine learning and deep learning model, the size of the variables varies with respect to the size of the model. So you can't visualize them. You can't visualize this, what happened inside one by one. That's why I'm trying to explain what happened behind the huge machine learning model with the small calculations. The same thing will be happening. Don't worry, once I map these two to the machine learning model, then you are able to understand easily again. So that's it. These 4 steps are repeated. Right? For example, I am trying to solve the same problem. So if you are able to participate actively, that will be more helpful for me. I will explain with hand calculation. Later, we will solve it using the Python. And later, we will solve it using the MATLAB. We have 30 more minutes left. I didn't take the break also because in between there is a power failure, right? That's why. See. So my problem is minimize f of x equal to x square plus 5. This is my problem. I want to solve it using the gradient descent algorithm. Tell me. So what the first step? And one more thing I forgot. So it is my function, right? It will be like this, my function. So this is actually like. Yeah, this is a function, right? I think you observed one parameter that is called eta, learning rate in the algorithm. So that eta, learning rate, is a value is lying between 0 and 1, between 0 and 1. The value of the eta is lying between the 0 and 1. That is called as the learning rate. That value is generally lying between the 0 and 1. Okay. So what is the significance of that means some value between the 0 and 1. So what happened if the learning rate is very small, and what happened when the learning rate is very large? We will discuss. If the learning rate is very large, that means the eta value is approximately 0.99 or 98, like that, very large. Let's assume my initial point is here. Initial point is here. Okay. I'm choosing the learning rate as a 0.98. So 0.98 means a larger learning rate, larger step length. Because your step length is depending upon what? Your step length is depending upon delta x is depending upon the minus eta, dou f by dou x. If your eta value is large, then your delta x also large. Your step length also large. If the eta value is less, your step length is less. All right. So if the eta value is large, what happened? Then your step length is large. Your step length is large. Still, I am not reaching this point. Then it goes to here. See, because of the largest step length, it is a skipping the optimal point. There is a possibility of the overshoot. This is called the overshoot. There is a possibility of the skipping of this optimal point because of the larger learning rate. Then what happened? From this positive slope to it goes to the negative slope. Then it thinks that, oh, I am in the negative slope. I don't go, I want to move to the positive slope. Then it comes back and comes here, comes here, comes here. And finally it landed. So there is a possibility of oscillations around the optimal point when you choose the larger learning rate. If you choose the larger learning rate, larger eta, then there is a possibility of the oscillations around this optimal point that you have to, okay. Hope you understand. See, if the eta value is large, then your step length is large. When the step length is large, there is a possibility of the overshooting. That means skipping of this optimal point. Once the skipping of the optimal point is going, then what happened? Once it is coming from the positive slope to negative slope, then I think I am in the negative slope side, I have to move to positive slope side. No, I am in the positive slope side, move to negative slope side. It will be oscillate around its optimal point. Okay, so oscillate around the optimal point. Okay, so that is the it may not happen every time. There is a possibility of getting the oscillations. There is a possibility of getting the oscillations, right? Now, what happened if the learning rate is very small? What happened if the learning rate is very small? So if the learning rate is very small, then what happened? Let's assume your initial point is here. If the learning rate is very small, then your step length is very small. So updated like this, 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 and finally it reaches the optimal solution. So when your learning rate is very, very small, then the step length is small, and it will take the more number of iterations to reach this bottom point. To reach this bottom point, oh, it will take the more time. It will take the more number of iterations to reach the bottom point, to reach that optimal solution. So that is the, but definitely to reach the point, no oscillations. If you choose the lower learning rate, no oscillations, but it may take the more number of iterations, more number of time to reach the optimal solution. If the learning rate is larger value, it may reach your global optimal point very fastly, or because of the large step length, it may leads the oscillations around its global point. Oscillations around its global point. So that you have to take care. That's why initially first 2 days, I am trying to explain with the fixed learning rate. Later, I am explaining the adaptive learning rate. In such case, the possibility of this oscillations may be avoided. I will discuss later part of the sessions. Okay. So hope you understand the impact of the learning rate eta when it is large, when it is low value, what is the large value, what happened, we'll discuss that. I think you are clear. Now coming to our problem, how we solve this problem using the nonlinear gradient descent algorithm. So anyone can help me, what may be the first step? So what will be the first step? Step 1. So step 1 is
randomly initialize a variable.
Initialize the variable. So initial variable I am trying to as x randomly from the minus infinity to plus infinity, some value I am choosing. So just I am choosing a value called 5. Just randomly I'm choosing 5. I can choose it randomly. I'm choosing. Next, what next? Any idea? we have to initialize our learning rate also, because this is eta. Learning rate also you have to initialize. So let's consider eta value equal to some 0.1. Some value I have considered between the 0 and 1. 0.1 consider. Okay, initialization is completed. And what else? Based on the discussion, one more thing we need to initialize. We initialize the random initialize the variable value and initialize the learning rate and initialize the one more thing I need to initialize. This is called as step 1 is nothing but the initialization. So one more thing is how many number of iterations you want to run this algorithm, max iteration or max epochs. So generally in the machine learning, the term is used is epochs. Epochs, EPOCHS, epochs. Number of epochs you want to use. So maybe like 100 or 200 or 1000, whatever it may be, like that. So these three parameters first you need to initialize. Okay. So what the step 2? Anyone please?
Calculate the gradient.
Gradient, right. So calculate the gradient. So that is the dou f by dou x at my initial point x equal to x naught. So dou f by dou x value is my function. Dou f by dou x value equal to 2x at x equal to my x naught value equal to 5. So this is equal to 10. Okay. So what the step 3?
Delta x. Delta x equals
Delta
to
x. We need to
minus
calculate the delta x equal to minus eta dou
eta
f by dou x.
f
That is
by
called
dou
gradient
x.
at my initial point x equal to x naught. Initial point means what is the previous value. So don't do this x naught every time. Initially we are at x equal to 5, x naught equal to 5. Later that will be updated. That's equal to minus eta value 0.1. And what is the dou f by dou x value? 10. That's equal to minus 1. Okay. And you can see here, I'm trying to erase this part. So this is how we are going. This is the f of x. Our solution will be here. Somewhere my point is 5. This is the 5 initially. Okay. Now initial point x naught equal to 5. This is the x naught value. Now I calculate the slope here. Now gradient calculated. Next delta x is calculated. Now what next? Step 4. So step 4 equal to update the x value. So update the x value means x equal to x plus delta x. So what is the x value here? What is the x value? Initial x value. What is the current x value? Current x value not updating. We are going to update. So what is the x value? 5.
5.
And what is the delta x value? Minus 1. That's equal to
Minus
4. Now see, now initially I am at 5. Now I am moving to the 4 because my point is here. I am trying to coming toward the optimal point. I'm trying to come toward the optimal point. Equal to 4. Okay. So what next? So it's completed. What next? So x is updated now.
Now our x naught itself is changing.
Yes. So again, we are updating these three steps iteratively until we are reached the maximum epochs. What we are mentioned here, the number of epochs we reached, until that we have to do this step 2, step 3, step 4 repetitively. So what is the step? Again, go to step 2. Repetitively we have to do. So what is the value? Step 2 means gradient. So dou f by dou x at x equal to x naught. So
Four.
dou f by dou x means what is the value? Dou f by dou x, that is the 2x. And what about x equal to x naught means?
4.
4,
Yeah.
no, not 5. It's equal to 4. Now what is the value? 2x, right? That means it is the 8. Now go to step number 3. That is nothing but delta x calculation. Delta x equal to minus eta dou f by dou x at x equal to x naught. So that's equal to minus 0.1 eta. And whatever the dou f by dou x at x equal to x naught, 8.
8.
That's a minus 0.8. Now step number 4. So step number 4, that's equal to x equal to x plus delta x. So x value, what is the x
4.
value? 4. Delta x
Yeah.
value minus 0.8. Now it is a 3.2. That means you are coming further nearer. 4 to 3.2, somewhere nearer. So slowly it is coming toward that slope 0 or optimal point 3.2. Now this is the second iteration completed. Again, go to step number 2. Again, go to step number 2 because repeatedly we are doing the same. So step number 2. Now, so step number 2 means the gradient. Again, calculate the dou f by dou x at x equal to x naught. So what the dou f dou x is the 2x, and dot over the x equal to x naught value, current x value.
3.2.
That means current x value.
Yeah.
3.2.
3.2.
3.2. Now it is a 6.4. Now step number 3. So what the step number 3? Delta x calculation. That is the minus
Delta
theta
x,
into dou f by dou x at x equal to x naught. So that's equal to minus eta 0.1. Dou f by dou x at x equal to x naught, 6.4.
6.
Now we have the minus 0.64. Right. Now
new
step
x.
number 4. So x equal to x plus delta x. Now what happened? X value is 3.2 minus delta x value 0.64.
6.4.
Now what I have? Maybe 2.2.
2.6.
3.
5.6.
No?
5.6.
5.6.
Yeah.
3.2 minus 0.64. 5.
So 5.6 is, yeah.
So we have to calculate. So so 3.2 minus 0.64, and we are getting the 2.56.
Yeah.
So like that, so this is the third epoch. Like that, the iteration value will be repeated until what we mentioned in the initialization, at the time of the initialization. So this is how we are using the gradient descent algorithm with a single variable only. Okay, so first we will try to write a code for this one, and later we will move to the multi-variable, because in case of the machine learning, it's not a single variable, we have the multiple variables. So how we will work with this one also we will discuss. So first I will explain about the coding part. Okay, first I will go with MATLAB.
Can I ask a question at this point?
Please, madam. Please, madam.
Yeah. Actually, now we have given the number of iteration as 100 or something.
Right, madam.
So after a while, actually, it will go to a negative point, right? X plus delta x.
Madam.
And then again, it will come back to positive. Some such thing will happen. So is there a way to optimize? Like we don't reach 0, but we are a little less value, positive value, then again, smaller negative value or something like that.
So,
Can we visualize
1
that?
minute, madam.
How? Yeah.
So that what I understood from your problem is, so after 10 iterations, it may go to negative
Yeah.
slope side.
Yeah.
And
And then come
coming
back
to
again
the
to
pod
positive.
slope side.
Yeah.
So
Oscillations.
that is depending upon how the choosing of the learning rate. So if we choose the learning rate very larger value, there is a possibility of that oscillations. It moves from the pod slope side to the negative slope side and coming back to the pod slope side and going to the negative slope side. So to avoid that one, it's better to start with a very small learning rate. If it's a very small learning rate, the possibility of the skipping that 0 slope, that is after 10th, first iteration, second iteration, 10th iteration, instead of going to the negative, it may land it in the 0 slope side. If it is the 0 slope side, then there is no point of updating the variable value, because our delta x is depending upon the dou f by
it
dou
will
x.
stop that point. Yeah, the algorithm,
that point,
even though,
it will stop
it
that
won't
point, even though
100
program will run, because we are giving the 100 iterations.
Okay.
Program will run, but the point will be stuck there only, because
Solution
the slope
will
becomes
be
0, no update.
Yeah.
Then the point question is, then why we are using for the 100 iterations? Instead of that one, try to go with a convergence criteria like slope equal to 0, gradient equal to 0. But that is not the case in case of this type of small problem. We can go with the gradient equal to 0, but in all the cases we don't reach that exact 0 point, 0 error or 0 slope point. Bottom peak point is not difficult in the case of the machine learning. In machine learning models are predicting a value or estimating a value very close, not exact. We are expecting exact, then we can give the 0, but not happening like that. That's why. So in the machine learning perspective, I am giving this convergence criteria as a maximum number of iterations. Otherwise, you can give the convergence criteria as a slope equal to 0. That's why actually.
Yeah. So how the algorithm actually gives you a solution based on when it is closer to 0 or when it continues to be the same or some such criteria is
So
there?
as close to as 0, closer to 0. We
Okay.
can't give the solution exact value. This is the exact solution. More near to the optimal solution.
Okay. Right.
So suppose that's why if we have a deterministic approach, like estimation of the roots of quadratic equation, something else, we have a deterministic approach like minus b plus or minus 2 b square 4 a to a. Exact value we are getting. In such scenario, it's not good to go with machine learning approaches. Academic purpose, we may explain small case studies, but it's not suggestible to go with machine learning because machine learning will not do the exact roots. It will close to that one, but deterministic approach will give the exact roots. So in case of the machine learning, it will give the solution as close as possible. And in case of the machine learning, our objective function is the error. Error means the difference between the actual value and predicted value. So we don't expect exact actual value. If the temperature I'm estimating 47 degrees means don't expect exactly 47 degrees. If we're expecting exactly 47 degrees, we will get the 0. But that's not the case exact. So if you give that 0, then your algorithm will not converge. Every time it will oscillate around that point. At least if there is an oscillation around the optimal point, it converges after 100 iterations. If you give the convergence criteria as a maximum number of iterations.
Okay. Okay.
No. So now we will try to work with this coding part. I'm trying to use with MATLAB. So as usual, CLC, clear all, right? So what's the step? Anyone, please? So first, I'm trying to randomly initialize the decision variable value, right? So you may go for minus infinity to plus infinity. Here I'm trying to go with some random initialization between some random values. That means lower value as minus 10 and upper value as plus 10. Somewhere, some random value I have to choose. Some random value between the minus 10 to plus 10 I want to choose, or minus 100 to plus 100, or minus 1000 to plus 1000. Some random value we will choose. So how we choose the random value? So my initial x value equal to the small logic actually. So you can write lower value plus rand multiplied by upper value minus lower value. Sorry. Lower value. So what it will do? Actually, rand is a function in a MATLAB. It will give the value between the 0 and 1. If you write, see, RAND 0.8147, RAND 0.90858, some random value it will give. Okay. Now I want to randomly generate a initial value between the minus 10 to plus 10. What it will do? If the rand value equal to 0, then my initial value x equal to low, that means minus 10. If the rand value equal to 1, the random value generated is equal to 1, then what happened? If it is the 1, what happened? Low plus up minus low. Low will be cancelled. We have the only up. That means my x value will be 10. If the random value is between the 0 and 1, some value between the 0 and 1, then my x value also between the minus 10 and plus 10. Just randomly initializing the x value between the minus 10 to plus 10. Okay. Next. So what next we have to do? we have to calculate the gradient. So gradient equal to, what is the gradient for our objective function? 2 into x. Our gradient of the object function equal 2 into x. So once you calculate the gradient, what you have to calculate? Update the x value. X equal to x plus, I don't know, please, anyone? Oh, not x, update the x value. What next? Once you calculate the gradient value, what we are going to do? Once you calculate the gradient value,
Delta x.
so what our next
Yeah.
step? We need to
Delta
calculate
x.
the delta x. Del x, right? So delta x equal to, how we calculate the delta x value? Minus.
X plus, yeah.
But eta is not initialized, right, here? So you have to initialize eta. So eta equal to some 0.1. Eta equal to 0.1. Some small value. So low minus 10 and plus 10. What else we need to initialize as part of this
Yeah,
one?
iterations.
Iterations, epochs. So epochs also we have to initialize, like I'm taking the, because computer will do everything. So I'm taking the 1000 iterations. So now initialization completed. Now we calculate the delta x value. Delta x equal to minus eta multiplied by minus eta multiplied by minus eta
Brilliant.
gradient.
Mm.
Gradient. That's it. So once we calculate the delta x value, next step is x equal to
X equal to
x
x plus
plus
delta x.
delta x. That's it. And these three should be repetitively updated until we are reaching the number of
Epochs.
epochs.
1000.
So for this one, I'm keeping all those three in a iterative loop. What that iterative loop? For iteration,
Epochs.
iter equal to 1 to epochs. 1 to epochs, and stop it. That's it. That's how we'll run. So we can already save this one. So
And the syntax end is necessary?
here I think so, madam, MATLAB. We'll see. Okay. Generally, but it's showing the error mode.
Yeah. Yeah.
MATLAB we required.
Yeah, yeah.
So that is a language to language, it will changes.
Yeah, yeah. Syntax is.
So if you run this one, so we
We are
want
not
x
asking
value.
it to print.
So f printf in MATLAB, we have tried f printf. Printf. So optimal solution is equal to something percentage some 0.2f comma our x value. That's it. So we are getting optimal solution. That means x value. Sorry, optimal solution. You can write x equal to. So you know x value equal to 0. So we are getting the x value equal to 0 because it is a small problem we are considered. So that's x equal to 0. So it's a very,
Can
very
we run
simple
10
case.
iterations actually?
Madam?
And see how it goes?
How many number of iterations you want?
Yeah, yeah.
So then what
If
we
we
will go?
reduce the number of iterations, maybe.
No. We will do one thing otherwise. I want to print the statement inside.
1000 printouts will be there.
Every time it will printing how it will update.
Yeah, but maybe we can reduce epochs to 10 something. 10 or 100, whatever.
Epochs equal to 10.
Yeah. Yeah.
So somewhere 0, like this we're
Okay.
getting, going back and coming back. And I will increase 100, 0. Finally, it's reaching that point.
Yeah.
Like that, maybe 1000 also it's stuck there. At 0, it's because our x value equal to 0, your gradient equal to 0, so that there is no point of updating. But it's a small problem we are able to visualize, whereas in case of the machine learning, it's very difficult to see all the things. So this is how we are using the MATLAB to write this part in the gradient descent algorithm. So I want to share this.
Okay, yeah. Class area.
And we will try for, I will try to Google Colab. We will try. So just I'm click. See, this is a Google Colab. Previously, we are using for the linear optimization.
Yeah.
Otherwise, I will rename it as a day one. Day one. So click on code. So again, we can use the same thing in the Python also. So now I'm trying to, and in Python we can code and text. Text means if you want to write something comment like this, we can use this text also. Text means maybe GDA we
Comments.
can write.
Mm.
Comment we can write. So we are writing here GDA. Now we can write the code here for what's called a gradient descent algorithm. So same steps we can follow here also. What are the steps we can follow? First initialization. Sorry. First we are going for the initializations. Get eta equal to 0.1. Sorry, 0.1 and
Epochs.
epochs. So epochs equal to 1000 and eta epochs and what else? Initial value
X equals.
x equal to, here is a function called random. I think random dot uniform. So random dot uniform between some values -10 to +10. So randomly initialize some value between the -10 to +10. So now we have to calculate the gradient. We have to calculate the delta x. We need to update the x. So all these things should be within the loop.
Yeah.
Iterative process. This is an iterative process. So for iter in range, so in Python, in MATLAB we are
Yeah.
using for iter equal to 1 to epochs like this. But here for iter in range of epochs.
1000. Okay, yeah.
Now epochs we have to call. Now we need to calculate the gradient. So gradient equal to 2 multiplied by x. X is available, so 2 multiplied by x. Once the gradient is available, calculate the delta x value. So del x equal to minus eta multiplied by
Right.
our gradient.
Yeah.
And update the x value. X equal to x plus del x.
Del X. Yeah.
That's it. Now we want print print our x value. So if you run this cell, so it may throw a small error because it don't know what the random where it is. Random function we are using. Yeah, we are using the random function, but it don't know. So we have to import that one. So import random. Import random, then run this. That's it. So x value, you can keep it around, then you can get some import numpy as np, and here you can write print np dot round of x. Zero. So 0 point we are reaching finally. So that's how we can write the code in the Python for this type of gradient descent algorithm for a single variable, very small one, where it is. Actually, the programming steps, we no need to follow same thing. So different people have a different logical thinking. So based on that, it will be changes. So this is how we are using the gradient descent algorithm to solve the nonlinear unconstrained optimization problem to find the optimal solution in a nonlinear unconstrained optimization problem. So this is a simple gradient descent algorithm. So here we are using for the single variable, but we can go for the multiple variables also. So multiple variables means, so go to, sorry. So let's assume we have a function called f of x comma y equal to x square plus y square plus 5, like this, for example. So now I want to find the optimal solution. So in that case, so what is our approach? Same thing. So step one is about the initialization of eta, initialization of the epochs. Anyone, please? What may be the next step? I
X
want
and
to use
Y
the gradient descent
initialization.
algorithm to solve this nonlinear unconstrained optimization problem. So eta initialization, number of epochs initialization. Next,
X and Y
right,
initialization.
we need to initialize the x value and y value. So that is the x naught and y naught. That's it. Step two. So what may be the next step? So next step will be,
Gradient. But
yes. So we need to
here,
calculate the gradient of
yeah.
x. So that's nothing but the dou f by dou x at x equal to x naught. Similarly, calculate the
Gradient Y.
gradient of y as dou f by dou y at y equal to y naught. That's the step two. So what may be the step three?
Delta X and delta Y.
Delta x and delta y. So delta x and delta y. So delta x equal to minus eta into gradient of x, and delta y equal to minus eta into gradient of y. This one, gradient of x, gradient of x.
Yeah.
Yeah, gradient of y, just gradient of y I am using. Step 3. Now step 4 equal to update. So that's equal to x equal to x plus delta x and y equal to y plus delta y. That's it. So this step 2, step 3, and step 4 again repeated for number of epochs what you mentioned here. So same thing will be used in the machine learning things also. We will discuss about that case in the tomorrow's class. But if you are able to understand these 3 steps of algorithm, so we are able to understand the machine learning, how this optimization method helps the machine learning model to update its model parameters. Hope you understand today's concept about the linear and nonlinear optimization and its implementations.
Thank you.
Yeah, thank you, madam. So if that's case, if it's okay, then we will stop for today. And tomorrow we will open with the programming implementation of this gradient descent algorithm multivariable. So later we will move to the simple linear regression model, and we will try to incorporate this gradient descent algorithm to update the model parameters of the simple linear regression model. So that is the tomorrow's action plan.
Right.
So
thank you. We can leave the meeting now.
yeah. So
Thank
any other questions, please? If anyone have any questions, please let me know. Otherwise, we will stop the meeting for today, and tomorrow we will start at 1:30. So every day from the 1:30 to 4:30. Meanwhile, we have a break from 3 to 3:15. So if anything else, please. Otherwise, I will stop the meeting for today. Once the video recording completed, I will upload into the YouTube and share with you. Okay.
Great. Thank you. Thank you, sir.
Thank you, madam. Thank you all. So I'm
Thank you, sir.
ending the meeting for today, and we will meet tomorrow. Thank you.